All right. Hello, my name is Rebecca Fitzhugh. I work for a company called Rubrik, but we're not going to talk about that. Backup's boring, right? So today we're going to talk about Terraform. So what I do at Rubrik is I'm actually the Director of Developer Relations and API Strategy, so all I talk about and think about all day is how can I automate things. And so that's where in the past few years we've really become big fans of Terraform, and I found that it has a lot of great uses, especially when it comes to managing at scale. So going to give you kind of the 100 level baseline today for Terraform, kind of get started, and I'll show you a bit of a demo at the end. So all of this kind of boils down to the ability to codify your infrastructure, right? And so APIs, again, this is a thing that I'm very passionate about, but not everybody wants to, I got the signal to move, not everybody wants to interact directly with APIs or learn a programming language, right? So there's more than one way that you can abstract away APIs, but APIs are the core of being able to do anything like infrastructure as code or configuration management. Now, with Terraform, and one of the reasons I like tools like Terraform is because it's declarative in nature, meaning I tell you what the end state is. So I will say, it's going to be a virtual machine, and it's going to have this many CPUs, this much memory, not an iterative process where you would say, I'm going to create a virtual machine, and then once I've created a virtual machine, I'm then going to mount an ISO, and then I'm going to install Windows. I'm not going to do that. I'm just going to say, here's the end state, go build it for me, right? So that's declarative. Now, this is where, depending on your use case for tools like Terraform, you might subscribe to this or not. But the original use and the original build of Terraform is really intended to build out and help you maintain an immutable infrastructure. Now, this is a bit of a change from how most people are operating their data centers today. Most people use a mutable infrastructure, meaning that you deploy that workload, and that workload kind of never dies, right? You keep upgrading it, patching it, and it just lives on forever. Whereas when you think about an immutable infrastructure, you deploy and destroy. Oh, I want to push out a new version? No problem. I'm going to push out the new version and then destroy the old, right? So we're going to talk in a minute about Terraform Destroy. This may be a function that you never ever use. You might only ever use it for provisioning, right? But its entire purpose was to be able to deploy and destroy in a very quick and automated fashion. So let's get into Terraform itself. Is this something, I'm sorry I'm talking very fast. Most important thing is seeing it in action, and I want to make sure we get to the demo. Has anybody used Terraform before? A couple of times? Oh, then you're experts. Get out of here. What are you doing? So the beauty of Terraform and what it's kind of actually only in recent history been shared and kind of brought down to the on-premises world. The thing that's drawn a lot of people to Terraform is the fact that it's multi-cloud. I can use the same tool to deploy to Azure, to AWS, to Google Cloud, to whatever the heck I want. And so now we're able to kind of extend that down to things like VMware, right? So you've got vSphere providers, you have your vCloud Director providers. And what a provider is this that translation from all of the available API endpoints and functions into HashiCorp configuration language, or HCL, that declarative end state where you just say, yes, create virtual machine, here's what it looks like, go. You're probably making somewhere between 10 to 75 API calls, but you might only have 10 lines of code, right? Because it's doing that translation for you, and that's what the provider does. So, first thing you need to do when you decide you're going to build this blueprint or you're going to build out a Terraform plan is that you're going to define what provider this is. So whenever I write any kind of code, I make a lot of notes because I try to make my code as reusable as possible, right? So I have a note that says, yeah, this first step is we're going to configure the Terraform provider for vSphere. So I specified what that looks like. And I literally just say provider vSphere, right? And then any kind of variable from that point forward, I can define that. So is it the ESXi host that I'm going to connect directly to, or a vCenter? What are those credentials? I could hard code that, but I personally prefer variables, right? Now, the next thing would be, if you are using variables, you need to define them. So at a minimum, you'll probably have two different files that you're dealing with Terraform. You're going to have your provider, which you may not separate into its own file. Some people will just create something called like a main.tf, or one big Terraform file that says, here's my provider and here's all the things I want to create. all in one big file, and then you have a variables file if you're using variables, right? I get a little bit crazy with mine, because to make it work for my brain, to help me troubleshoot a little bit more, I actually break every single type of object into its own file. So you'll see that in the demo, but that's not required at all. So with the variables file, you'll just name it variables.tf, and you can go ahead and define what those variables are. Now for me, again, I try to make my code as reusable as possible, so I will define what those variables are and the type of variable in a variables file, but I don't actually put the variable in here. I'm not actually saying password is Rebecca's the best, right? I could, but I personally don't. I break that into a completely separate file that's a TFVars file, right? Which allows me to now, if I'm using something like version control, I can now say I don't want to push this to GitHub because I want to keep my usernames, my passwords, my IP separate, but here's the variables that I'm using, right? So you have the option of defining them here or not. Now once you have built out your main.tf where you're saying here's what it's going to look like at the declarative end state, now I want to actually build something, all right? So I will go through and I will say Terraform init or initialize, and what this is going to do is it's going to download the provider that's compatible with the platform you are using, right? It's going to download the most up-to-date version. So even though I might already have my vSphere provider downloaded, I will tend to still begin a plan by saying Terraform init just to make sure I have the latest provider downloaded. Now I need to specify resources, right? So that's that declarative end state. And so documentation. Look at the documentation. It will tell you what type of objects are available for you to create, right? So in this case, we've done something very simple. We're creating a resource, which is the correct Terraform vernacular for creating an object, and I want to create a virtual machine. Now, I've tried to make this a little bit more complex so you can see how granular you could be if you wanted to. But I'm going ahead and say, I'm going to name it, and I'm going to specify this resource pool, this data store, this number of CPUs, this much memory, this type of operating system, and so on. To the point where I can even point it to a bootstrap file and have it automatically install the operating system. Or what I've also done here is I've deployed from templates, so I don't even have to bootstrap it. Now, in your command line terminal, once you have Terraform installed and you have your provider downloaded, you can do something called a Terraform plan. And a Terraform plan will have it hit those APIs without actually executing. So it's going to get information to make sure that those resources that you're calling to are actually available, right? Make sure that everything's online. Make sure that it runs through the motion without actually creating anything to let you know of any kind of debugging or errors. Maybe you've improperly formatted something. Maybe you're using the wrong syntax, or you're calling to a data source that doesn't exist. By doing a Terraform plan, it will return all of that information for you so you can start troubleshooting and debugging your plan before you actually execute it. And then when you're ready, you will just say Terraform apply. And this is where you get to watch it think for a second. It might take a few minutes depending on what you're doing, and then tell you it's done, right? So this is where I sped up my demo a little bit. Am I allowed to say maybe something a little bit not nice about VMware at VMworld? The API endpoints are a bit slow for VMware compared to some other providers out there. So I sped up the video to make sure it goes a little bit fast. And then once you're done, if you say, oh, you know what, I screwed up that provisioning, or I actually don't need that resource anymore, Terraform destroy, right? So for my team, I run an engineering team. We do a lot of test dev, and we run a bunch of different operating systems. So we have a bunch of pre-built templates, and we Terraform apply, do all the testing, and then Terraform destroy at the end of the day. And then you have the backup of the state, right? So you have these backup files that are available to you that always have the most up-to-date backup of your Terraform plan that get automatically created for you when you do a Terraform apply. All right, I got the 3-minute warning, so let's get into this demo. It's about, I think, a 2-minute demo. So like I mentioned before, I personally like to break my files up into multiple files rather than just having one big main.tf file. So the first thing I did was define that provider. Now secondly, I'm showing you in about 50 lines of code that I am specifying what that virtual machine will look like when I'm done. I love variables. I hate hard coding things, so I have tons of variables, right? The data store, the network, the host, and so on. And then I'm showing you my password. Look at this. My Terraform.tf vars. That's where I actually say what that variable is if I don't want to hard code it in that file. And then now I'm just going to say Terraform init. It's been successfully initialized. I'm going to do a Terraform plan here. It thinks about it, says yes, everything's good. I'm going to create one resource for you, and here's what it's going to look like with all of the things that I have defined. And then Terraform apply, if I spell it correctly. So you can see it actually calling to all of the different data sources, the things like your data stores, your networks, and so on. And it starts the creation process. Now, if this was a little bit of faster API endpoints, this could be potentially near instant, like it would be for AWS, for example. I obviously, again, sped that up, but voila, I have now a virtual machine created in the data center that I specified, on the data store I specified, connected to the network I specified. And I have configured this script to have an output here, right? So it tells me the IP address and it verifies the name and the GUID of that virtual machine. And then now I say, you know what, I'm done with it. Terraform destroy, and it says, wait, are you sure? Yes. And then it will go through, power it off eventually, and then destroy it, right? And you see the delete process happening, right? So, like I mentioned, this was meant to be kind of an introduction as to what you could do. So, don't start over. Oh, you can't see it. I will tweet it out. I have all of this on GitHub for you, so if you wanted to grab that code and use it, you can, right? So exactly what I just shared, just not my passwords. All right, thank you very much.